let's go. Time for testing. Do we have any searches? Nice. Cool. Nah, fuck that. I'm gonna just keep iterating, make a better one. Come on. Wait. It's giving answers. I'm just gonna have it do it again. What? Why was it putting the answers in there? Don't answer after each question. Oh my god. That should be obvious. Alright, that was the last pro search. Oh my fucking god. No. Put the answers at the end, not after each question. Wait. Oh my god, and it stopped. Oh no. Alright, let's just... Hold on. Whatever, we're not gonna get online stuff, but... Excuse me. I'm gonna do push-ups for a sec while it's loading. It's still loading? Oh, my camera's not even on. Oh, GG. Alright, well, whatever. 3 negatives. Okay. Camera good? Cool. Cool. Well... No. Bro. Hello? Okay. I don't even know what the... I don't know what the operator's even called. Declare a pointer by entering the data type it will point to, then an asterisk immediately after. Asmongold XQC. I'm not gonna say ALGORITHM. Declare a pointer by entering the data type it will point to, then an asterisk immediately after, a space, then the pointer's identifier. The pointer can be left uninitialized pointers are called, an uninitialized pointer is called a wild pointer, a garbage address, be signed an address later. Probably more safe to initialize pointers with cool 69. We can pass an object by reference or const reference by giving the receiving function, non-const or const and const reference. L value references. and calling the function with the objects we want to pass by reference. Example, int x is 5, const standard string name Ethan. Void print stuff. Int reference number, right? Const standard string reference name. Print logic. Well, rather we could do. Okay. Cool. Number accessed via reference is space the number, which is a reference to a modifiable value. And name via const reference is his name. Cool. 68. L values are non-temporary objects. Are named non-temporary objects. R values are unnamed temporary objects. Int x 5. X is an L value. Sure, that works. Can I even... Cool. Yeah, it's just an expression statement. All right. Non-const references can refer to L values. L values and non-const are to modifiable L values, but not non-modifiable L values or R values, or any R values, or R values. Const references can refer to modifiable L values, non-modifiable modifiable L values and R values. Reference is an alias for an object. If the object and reference are non-const, the referent object can be modified by modifying the reference. If the object and reference are non-const, modifiable, the referent object can be by modifying the reference. References and, well, references and their referent, or, well, a reference and its referent have independent lifetimes, except for const references and R value reference and reference. A pointer is a variable, well, named alias for an object, but it is not an object. I don't really know what a pointer is. Is a pointer a variable? I mean, it's storing information, right? I think it's a unique thing that stores address. Is an object that stores the reference of another object. It can dereference the pointer using the unary operator asterisk operator dereferencing. Change or read the value at that address. 66. A non-template or non-type template parameter is a template parameter with a type that we pass during a template function call to pass a const expression value. To the template function. A function template is a what is a function template? It's a, well, I mean, I guess it's a function. It's a placeholder function that will generate versions of the function with identical logic, but parameter type, or, well, but return and parameter types. Well, hold on. Yeah, return and parameter types match the types of the arguments, call arguments. A function template is a placeholder function that will generate versions of itself with identical logic, unless excluding explicit specializations, with identical logic, but return and parameter types that match the types of call arguments. Excluding non-template excluding non-template non-template parameters. It's a placeholder function with placeholder type name parameters non-type all non-template parameters. When the compiler sees calls to the function template, it will instantiate versions of it with return with the placeholder return type and or parameters replaced with the appropriate to match call arguments. A separate version will be generated for each unique argument, or for each call with a unique set of arguments. Function overloading is creating multiple versions of a function that differ in parameter type and or count. The calls will call the appropriate version, version that most closely matches its arguments. Calls may be ambiguous, yielding compilation errors. If it argument conversion, or if an overload is not an exact match to the call, and conversion makes multiple overloads equally viable. The auto keyword for objects sets the object's data type to the data type of its initializer. For function return values, the return value type is set to match the type of the return value in the function. For function parameters, function return type, trailing type. What is it called? You put auto in the beginning and then it changes the type to be whatever false. So trailing type, auto trailing type syntax lets us put lengthy return type names after the, or at the end of the signature, and auto at the beginning to increase readability. For function parameters, auto is a shortcut that generates an abbreviated function template where auto is effectively, or auto serves as a placeholder type name that gets replaced during function instantiation, or during template function instantiation with the type of match argument, call argument types. 62, a type alias, a way of referring to a data type with a different name. Excuse me. You can use using or typedef statements to do this, i.e. examples. Using bignum or bignum for int64t. Typedef name standard string as name. Aliases int64t as bignum for convenient and funny use. Okay. Aliases standard string as name for quicker use. Static cast is an explicit cast that lets us explicitly convert one data type to another. This prevents the compiler from erroring about signed, unsigned, or narrowing conversion mismatches or narrowing conversions. If I want to print a character, a character as an int, I can cast the int character to be an int. I can cast a standard string view to become a standard string, since no implicit conversion exists. Not really sure how that works. If the conversion isn't implicit, I guess static cast has extra information about how to cast things. Implicit type conversion is how the compiler converts data type A to data type B when data type A is passed to an object of data type B. Or if an arithmetic operator expects two of the same data type, implicit conversion converts one data type to the other via usual arithmetic conversion rules. I'm gonna skip 59. Going back to the jumping around a little for time's sake. It didn't give me const expression functions. That's annoying. It's too hot. I can't wait to cook. 51. I don't know. Is it if switch block? Well, that's a compound statement. Switch if. I mean, I guess loop? Yeah, I guess loop controls flow, right? Because it goes from being sequential to. I guess so. I mean, maybe go to as well, but. If statement, switch statement, loop. If statements check a condition and execute nested logic if true. Useful for ranges. I'll just say that. How does an if statement work? If statements evaluate a condition and execute nested logic if the condition is true. Switch statements switch on a compare the switched variable to explicit case values. And execute the next logic that follows the case, which might not immediately follow the case. The follow through. Use switch statements when you want to check multiple explicit values more conveniently than an if-else statement. (54) While condition logic do while do logic while or condition 4 int definition or well, sorry, loop variable definition condition loop variable condition loop variable change to something like that, i.e. for int I is 1 or I is 0, I is less than 5, increment I. Okay. break exits the nearest switch statement or loop. Resuming at the immediately after. Oh, well. Break exits the nearest loop and resumes control immediately after. Same for switch statements. Step 1. Initialize standard seed sequence with seed values to properly seed Mersenne twister. Initialize with a steady clock for big random-ish value. Big approximate random value. And standard random device for OS random numbers. Step 2. Seed Mersenne twister. Initialize seed Mersenne twister with the standard seed sequence. Step 3. Call Mersenne twister identifier from standard uniform in distribution initialized to our range 1 3 1 3 numbers 1 to 3 by calling the example standard seed sequence, standard chrono, steady clock, now, time since last epoch, dot count. Oh. Static cast to standard Mersenne twister 19937. Result type. Can't remember how the syntax is. Yeah, so no function part. Alright, cool. Result type. Static cast to a Mersenne twister result type. Steady clock. Ah, fuck it, it's fine. I can do the syntax, I know how to do it. Okay. Sure, we'll do 43. Compound statements. are sections of scope that begin with this and end with this. Variables created within are destroyed at end of scope, since they are local variables. Well, yeah, sure, not really. I guess not, because we could have a block within a namespace and the variables in there, I guess, yeah, aren't really destroyed, because we could just go to the namespace. Yeah, because they're in global namespace, so they aren't destroyed at the end of scope. It's just a separate block in the namespace, maybe, to section things off. We can use a block as an if statement, switch statement, or loop statement, so the whole block executes the conditions are true. Local variables. Created at definition when during their functions execution, and destroyed at end of scope. Often functions end. Global variables are created at compile time and initialized. And initialized at not compile time, at runtime. Program start. And destroyed at program end. Global variables are accessible everywhere in the pilot is aware of them. Accessible in all files that have 4 declarations to them. 4 declarations or definitions to them. Local variables are not accessible outside their functions. 45. Variable shadowing is when the compiler calls an inner variable. Is when calls to an inner variable, or calls to a variable. Call an inner variable, is when an inner variable's identifier masks an outer variable's, or when an inner variable showing an outer variable's identifier masks the outer variable, or masks calls, or prevents calls to the outer variable using that identifier. When an inner variable sharing an outer variable's identifier prevents calls to the outer variable when calling the identifier. Linkage describes whether a function, an object or function is visible to the linker and what files it's usable within. Static functions and const expression and non-extern const expression variables have internal linkage and are invisible to the linker and only usable within file of definition and any files they're included in. So if I had a static function in a header file and I included it in one file and then I included it in another file, it's static. So it's only, the linker isn't even going to look to duplicate them, or it's not even going to look to check if we're violating the ODR. That's why we can have a const expression variable in different spots. It's just that we do it inline to make sure we're not wasting memory. Global variables, non-const, oh, oops, hold on. And, oh, non-extra, okay. Non-const, const expression variables, global variables. And non-static functions have external linkage where any file visible to the linker and any .cpp file in the program can use them, provided they aren't in an unnamed namespace. And those in an unnamed namespace and that the .cpp file forward declaration. Okay. Const global variables are unsafe because they can be changed anywhere they're used in the whole program, which makes debugging tedious. Inline variables are variables that the linker deduplicates. Well, variables are global variables that the linker deduplicates to let all instances use the same one place in or share one place in memory. Particularly useful to make const expression global variables or global const expression variables efficient by not having an individual copy in every used.cpp file. Static local variables are local variables that are created at runtime, initialized once during the function's during their function's first call, and destroyed at program end like a global variable. Scope is still local, since they aren't destroyed between calls. Their value persists between calls. Namespaces provide sectioned pieces of global scope to avoid name conflicts and split and compartmentalize logic that should be compartmentalized. Standard string is the standard library object. Unlike C style string being an array of const characters. Well, of const. I guess it's pointers to const characters. So now it's so C style string is what, a dereferenced const character address when we access it, something like that. Well, and I guess the point is it decays to a pointer. So it's a value, but we have to reference it through something. Yeah. Is an array of const characters. Standard strings are expensive to copy. And I guess it's one well, but they could be both. They're both one object. C style string, which is an array of characters, which decays to a pointer you can use to access specific elements, characters in the array. Standard string view. Is a cheaply copyable view of a standard string or okay. Okay. What else is, or is it equivalency? Oh, yeah. Hold on, it's relational. Less than, greater than, less than or equal to, greater than or equal to, and not equal to. I think those are all probably relational. And then and or. This and this, or this or this. I think that's it. Okay. At least 4 fundamental data types. Okay. Hold on. Yeah. Okay. A string literal. Okay. Okay. I'm using values instead of variables. I'm used to saying L value and R value, I think that's why. What else? Sure, I think that's it. Okay, what else? I think that works. Nope. Well, I meant value, like value initialization logic. Okay. So the point is, as long as the asterisk is with the identifier or with the type, it's okay. But it makes more sense to do it with a type. That way we're saying, hey, this is a pointer to a function and not a data type, and then we're dereferencing an object. But regardless, it's not dereferencing an object because the type exists. Excuse me. I guess you could say in that case it's almost, well, I guess it's not an operator. I was gonna say it's a binary operator with a type on the left and an identifier on the right, but I don't think that's right. Null initialization should use null pointer, meaning we've set it equal to null pointer. Well, I meant if it was default, if it wasn't initialized during declaration, it has some garbage value, and if we declare one like that, ideally we should just initialize it with null pointer, with the value initialization, and then later on assign it a different address to point to something else. What is this null pointer shit? Let's see. Seems like they're the same. So value initialization makes it point to null pointer by default. Can be reassigned to point to different objects. So passing it a name, we're initializing. Oh, I probably said that really wrong. Oh, well, I'm saying pass name's address, but it's really initialized with name's address. I mean, sure. Initialize instead of passed. Okay. Improvements. Calling the function with the objects. Call the function with the objects we want to pass. Well, the caller passes. Oh, but I think I said calling them with the objects. But, well, I mean, we're passing the variable. Well, I mean, the object, not necessarily just the variable. But, well, I guess it's named, so it is a variable. Yeah, but we don't, it doesn't have to be a variable. Yeah. Yeah, I agree. Yeah. Passed by const reference avoids unnecessary copies. Not necessarily true because it doesn't have to be a const reference to do that. And even with a const reference, we might still get issues because we could do a const reference for a standard string to a string view, and that standard string will still be copied. It's just that it's cheaply copied to, it's cheaply copied to a like if we have a standard string reference and I'm passing it a C-style string, that C-style string will be copied to a temporary object at the standard string, which we will then use as the reference. So even if I do a const reference, it's not necessarily true, I think, that we avoid unnecessary copies. Non-const L value references can only bind to non-const L values. Yeah, makes sense. Non-const references can refer to modifiable L value, wait, what? Refer to? Non-const references can bind to modifiable L values, but not non-modifiable L values or L values. Yeah, true. Or you could just say, can only do this. Yeah, that makes sense. Const references can refer to modifiable L values. What? Oh, well, yeah. Yeah, that's true. Okay, cool. Well, then you didn't need to put that as an improvement. A reference and its referent have independent lifetimes except for constant references and with R value bindings. References must always refer to valid objects. Dangling references are unvalid. Yeah, exactly. Yeah, sure. Yeah, I don't think that's helpful. A reference is not an object. It's technically right, but it could be confusing. References are not objects in C++ terminology, but they behave as alias to objects. Yeah, exactly. I mean, that's literally what I said. I said it's an alias to an object. Clarify that parameters must be constant expressions and their types are limited. Hold on. Well, yeah, for non-type template parameters, they must be constant expressions. Yeah. The types are limited. Integral, pointer, reference. Oh, well, I didn't know that. Okay. So non-type template parameters must be integral types, pointers, references, constant expression to bullshit. Well, yeah, it makes sense. I think that's in the definition because a standard string can't be a constant expression, so we can't pass a standard string. That makes sense. Consider templates use type parameters. Okay, a type parameter and can accept non-type parameters. Yeah, sure. Can accept non-type parameters, meaning if it has a non-type template parameter. Oh, you mean a non-type parameter like a regular parameter too. The compiler generates a unique. Yeah, exactly. That's what I said. Overload resolution is based on the best match, and ambiguous calls are compilers. Yeah, I said that. Trailing return type syntax. When using auto for function parameters, it creates a function template. Auto for the return type with trailing syntax is useful for complex return types and whatever the fuck a lambda is. I guess it's the that one with ellipses. I've seen a lambda and it had the dot dot dot. Type def standard string name is legal, but by convention type name should be capitalized. Oh, whoops, sorry, I forgot to capitalize my type def for my aliases. Prevents the compiler from, hold on. Oh, did I say this? Oh god. Constructor to create the object, I guess. Prevents the compiler from erroring about that is not quite accurate. It doesn't prevent errors. Well, Yes, it would, because if I explicitly cast 4.0 to be 4, or to be an integer, normally that implicit conversion yields an error in conversion. And it is an error in conversion, but it prevents errors for them. It makes the compiler not care. Huh? The standard string view to a string would be a conversion, so it would be creating some sort of object, initializing it with those values, and then, yeah. Implicit conversions can lead to bugs and whatnot. Okay, makes sense. Yeah, because we don't expect exactly what's happening. Clarify that loops include for while, do while. Yeah, well, I just said loop. Yeah. Mention that the only block following the if is executed if the, I said if it's true. Okay, bro, you tell me to do something, and I say it that way, and then you criticize me for saying it that way. Okay. Switch only works with integral or enum types. Okay. My right eye is like twitching with the alarm. For clarity, mention that loops are often used for counting, while for indefinite repetition until like something happens, and do while to guarantee at least one iteration. Yeah, makes sense. Oh my god. Okay. Alright, let me continue this. Still have 2.5 hours before bed. This schedule is insanely good. Carefully breaks, exit the switch, but continue cannot be. Well, yeah, but we didn't talk about continue. I said break can be used in that. I didn't mention continue, buddy. Random devices used for seeding. Standard seed sequence is optional. Well, I mean, okay, buddy. Those define the block in the lifetime, sure. Explanation, accessible and all. Hold on. For external linkage, well, yeah, in order to forward declared, it must be declared extern to say, hey, it's forward declared somewhere. This isn't the in the other files, it must be declared extern so that it's not default initialized with a garbage value. Okay, only usable when the only usable within the wait, hold on. Well, yeah. If I use it and if I include a header file into different other files, that logic is usable in each one because each one is invisible. Its own translation unit is isolated from the linker. Cool. Thread safety, I don't know anything about that. Inline variables are available, I don't know that. Since C++ 17, okay, it's fine. I already did say that for static local variables. Can mention the scope resolution operator. Well, yeah, we can if it's a namespace one that's being shadowed, sure. Well, yeah, and that's how you do it, sure. Standard strings are expensive to copy. Copy on write or move semantics to mitigate this? Yeah, I don't know how that works. Standard string does not own the data, so the original string must outlive the view. Meaning that if the original string leaves, I'm not super sure how the standard string works. If it's like if it's a reference but it's different, I'm not super sure. I just know like when to use it. Can mention the importance of parentheses for clarity. Well, yeah, makes sense because you're not gonna memorize all of them. None, and then epsilon value. I don't even know what that means. An epsilon value for approximate comparison. Oh, like the squiggle, maybe. Oh, an epsilon value, meaning like comparing it if it minus this is within a certain degree of uncertainty. Yeah, makes sense. List the main types. Could clarify that those are floating point types. Well, yeah, float, double, and long double. The floating points, those are integral. Well, all the others are integral, but those others are integer, sure. Decrementing, could clarify this is due to underflow. Well, oh, I guess we're saying overflow and underflow. Oh, noted. Well, I mean, it is modular wrapping, but didn't know it was called underflow. Noted. On-site integers are best used for bit manipulation and whatnot. Yeah, makes sense. Yeah, sure. Stream size unrelated. Well, yeah, but I was just telling you that a size t is the size of a stream size. That's what gets returned. It's a size t value. Yeah, that's exactly what I said here. Exponent is always base 10. Percent of notation, sure. Turn false, yeah. None. Explicit conversions as well. Well, yeah, I mean, I already covered those earlier. None. Const expression variables can't be forward declared. True for non-inline const expression. Yeah, but it's not forward declared. It's still defined, you fucking idiot. Alright, cool. Sounds good to me. Cool. I like this study strategy, honestly. The weekend 6-hour-a-day thing is fun. I don't feel burnt out or anything. The day is fucking over, but I've spent a whole shitload of time screwing around, but I've still studied a lot, so. I mean, I'd want to study more, but I don't feel the desire to, and I think I'm good. Got a lot of new information in the brain today, and I feel like I have a good grasp of it all too. So let's go.